Hi there, Math 126 students. In this video, I'd like to talk about that second part of the exam. So in my previous video, I talked about chapters 12 and 13. Now let's talk about what if we're asked something about chapter 14, which is all about critical numbers, finding derivatives, second derivative tests. That was this piece of the course right here. So absolute max min, applied max and min. This will definitely be on the test, probably a couple pages from that stuff. So let's go look at some old finals, see if we can find such a question. So here's the winter 2022 final. Let D be this triangular region, find the absolute max and min. Okay, so draw the region. 0, 0, 0, 6, 3, 0. Here's the region. Done. And then ultimately we have four jobs to do. The partial with respect to x, 2x plus y, the partial with respect to y. There's a minus 2 here I missed. Set them both equal to 0. This is the smallest part of the problem. Then you get x equals 0. You plug that in. So again, I like to make this little tree from equation 2. X has to be 0. Substitute that into equation 1. And then you get 0 plus y minus 2 is 0. So y has to be 2. So you get this point 0, 2. Now 0, 2 technically is part of the region, but it's on the boundary. So you actually don't need to plug that in. It doesn't hurt to plug it in. But the reason you don't need to plug it in is you're going to be analyzing that boundary later. But let's plug it in anyways. Plug in x is 0, you just get 0. Okay. Now the real work begins. So we have this boundary, and this boundary. You want to describe those boundaries, including giving the endpoints of those boundaries. And by endpoints, we actually mean the largest and smallest the variable can be. Okay, side 1. Y is 0, and the endpoints are x can be from 0 to 3. And we're going to write down the one variable function above this side. When we plug in y equals 0, we get x squared minus 2x. So I know that I am going to plug in 0 to this side, which is going to be 0, 0. I know that I'm going to plug in 3 to this side. Those are the endpoints of my one variable function. And when I plug it in, I get 0. When I plug in a 3, I get 9 minus 6, which is 3. Okay, in addition, for one variable functions, you have to find when the derivative is 0, and in this case, you get x is 1. So I also need to plug in a 1. And you get negative 1. Okay, on to the next side. So this is the idea. I think most of you are getting this now, if you didn't have it going into the exam. On this side, x has to be 0 and y has to be between 0 and 6. So now I'm going to plug in x is 0. But that just gives me 0. So in fact, on this side, I don't really need to plug in the endpoints or anything because it's 0 everywhere on the entire side. Okay, last side. So I did plug in the endpoints and I did plug in the critical numbers. I plugged in everything. They're all 0 on that side. So currently at this moment, this is the winner and this is the max, this is the min. But let's keep going. You get to the last side, I need the equation for that. It's a line that goes through the points 0, 6, and 3, 0. So the slope is going to be 6 minus 0 over 0 minus negative 3. So the slope is going to be negative 2. Y equals negative 2. The intercept is 6. So that was probably the hardest part of this problem, was finding the equation of the line. X is, if I choose to use x is between 0 and 3. Alternatively, I could rearrange this equation in terms of y, in which case I'd want to say y is between 0 and 6. I don't know what's better. It just depends on the equation, what would be easier to plug in. Would it be easier for me to substitute for y or substitute for x? I think it's easier to substitute for y, so I'm not going to do that because there's only one y to substitute for. Okay, so this is going to be f of x. I'm putting in negative 2x plus 6 for y. So I'm going to get x squared plus x negative 2x plus 6 minus 2x. I would simplify that. Minus 2x squared plus 6x minus 2x. So it's negative x squared plus 4x. Okay, and then on this side, Now, technically, I've already plugged in the endpoints because the endpoints are here and here. And I already plugged in this endpoint here. And I already plugged in this endpoint because it was on this side. So a lot of times in my solutions, I don't explicitly show that, but in your mind, you should be thinking, okay, am I checking x equals 0? Yeah, that gives me z equals 0. Am I checking x equals 3? Yeah, that gives me, it's nice to double check, -9 plus 12, which is 3. Yay, it's the same. Okay, then you also need to take the derivative. 2x plus 4 equals 0. You get x is 2. So there's one other thing I should check, which is what if x is 2 on this side? That is in the boundary. So that's going to give me z equals -4 plus 8, which is 4. And that indeed is the max. If the question asked me for the point itself, I would have to go back and say, okay, on this side, if x is 2, y is also 2. Is that right? Is that reasonable? Yes. Okay, so then this is the max. This is the min. Okay, so that's another max and min. Let's see, did this exam have other ones? Oh, I did those partial derivatives. I think that's part of my last video. I forgot that's a chapter 14 topic. Let's look here. Find and classify the critical points. So you would do the partial with respect to x is y minus y cubed equals 0. The partial with respect to y is x minus 3xy squared equals 0. Probably easier to start with this one because it factors. And that gives me y equals 0 and y equals plus or minus 1. So then there's, if you start with equation 1, there's 3 things that can happen. Y could be 0, y could be -1, y could be 1. And then for each one, plug that into equation 2 and see what can happen. So if you plug 0, then this gives you x is 0. So that gives you 1 critical point. So I just plugged in a 0 here. If you plug in -1, you get x minus 3x equals 0. So x has to be 0. So -1, 0. And when you plug in 1, you also get 0. So you get 1, 0. Okay, that's that game. I don't think I'm going to make this video really long. Can we do critical points? Can we do partial derivatives? Let's look at this exam. This is the one I walked through. Right. Can we do? We just did that recently on the last exam, so I think I'm going to stop that there and leave the rest of the questions to the discussion board.